Greetings, aviators. My name is John Walls, and I'm studying for a Bachelor of Science in Aviation at Liberty University. Today's presentation, I will briefly discuss the four forces that affect flight. The forces of flight that we'll be discussing today are thrust, drag, lift, and weight. Thrust is generated on an airplane by a propeller or turbine, or in some instances even rockets. Thrust moves the airplane forward through the air, and it works to counteract or oppose drag. When the thrust is greater than drag, the airplane accelerates. However, when drag is greater than the amount of thrust being generated, the airplane in turn decelerates or slows down. When the force of thrust and drag are equal, the aircraft will maintain its airspeed. Drag is the force that opposes thrust. As an airplane moves through the air, there is friction from the air itself running into the aircraft. There are two types of drag that affect flight. The first type of drag we will discuss is induced drag. This type of drag can be a little difficult to describe, but it is simply drag caused as a result of the creation of lift. The same way a water ski glides on top of the water at a slightly tilted backward angle, this is also true with the wing of an airplane as it flies through the air. With that in mind, imagine induced drag as the same resistance caused by water on a water ski except with air moving around a wing. The second type of drag we will discuss is parasite drag, also known as form drag. Parasite drag is simply the air running into parts of the airplane. Parts like antennas, rivets, tires, the windscreen, your arm sticking out the window, or anything and everything that the wind hits causes parasite drag. Lift is defined by the Pilot's Handbook of Aeronautical Knowledge is a force that is produced by the dynamic effect of the air acting on the airfoil and acts perpendicular to the flight path through the center of lift and perpendicular to the lateral axis. In level flight, lift opposes the downward force of weight. Lift can also be explained using Bernoulli's principle. From the diagram, we can see the pressure on the upper surface where the flow is moving faster is lower than the pressure on the lower surface where it is moving slower. The pressure difference creates a net aerodynamic force pointing upwards, what we experience as lift. Last but not least is weight. Weight is the combined load of the aircraft itself, the crew, the fuel, and the cargo or baggage. Weight is a force that pulls the aircraft downwards because of the force of gravity. It opposes lift and acts vertically downward to the aircraft's center of gravity. In the illustration, it shows that 2,250 pounds of lift is generated by the wings, is enough to overcome the 2,000 pounds gross weight of the aircraft, thus making flight possible, all while being balanced by the 250 pounds of downforce on the tail, allowing straight and level flight. By manipulation of these forces, it enables the aircraft to be maneuvered. In summary, flight in an airplane is made possible by a careful balance of these forces. An aircraft's lift must balance its weight, and its thrust must exceed its drag. A plane uses its wings for lift and its engines for thrust. Drag is reduced by a plane's smooth shape, and its weight is controlled by the materials it is constructed of. Although aircraft come in a vast array of shapes and sizes, serving a multitude of purposes, the laws of physics that govern them never change. I hope you have found this information valuable, and I pray that God will bless you in all of your endeavors. Thank you for watching.